some new stuff today.
Hopefully. If it's review, then we'll ask you questions. We will. I think we had about 16, 18 people signed up, so we'll just wait a couple more minutes just to see if somebody else shows up. And make sure you sign in on the sign-in link down there. Actually, while we're waiting, I suppose we can do the get back. All right. How many of you have already gone through the instructions to get the code for today's session? You've already gone through it. Okay. All right. Well, if you're doing it right now, that's great. Those of you that have done it, how many of you did it yesterday or today? Today? Okay, so then you're fine. You did it today? Okay, today. Did you do it? Pardon me?
Like last week.
Oh, okay. All right.
I saw that you are changing something.
Yeah, so we've got it in a different folder now, so you can just redo this job. So go to the gitlab.rc.uab.edu /rc-training-sessions/singularity_containers. So the link from the email. Let me see if I can put it on sticky notes, make it big. No, it just makes it unreadable. That's not helpful.
Yeah, not bad. That should be enough. After having them, I guess.
After adding everything.
No.
It's not working for me either.
Right format.
Format.
Font.
Oh, there we go. All right, so if you go there and then just follow the instructions here to copy and then come to the job composer and new job from default template, go down to the bottom, open the editor, and copy, paste, save, and then you can run that job. Then you'll have the most up-to-date things for today. If while we're going through the notebook, it looks like your version is not the same as what Ravi's going through, one of us will come over and help you do a git pull to get the most recent version.
A quick question.
Yes, sir.
When I was able to do this right, I will also be want to know what is happening behind the scenes. What do you do here for, I mean, the R Studio to connect? How do they connect? Because I'm doing this on a different interface, I'm doing this on R Studio. What is happening?
Sure. So for this particular session, we're going to be using Jupyter Notebooks, but the same kind of thing applies as did for the R session last month. What's happening here is that we are writing a job script to clone the code from an online repository into your personal drive on Cheaha. Okay, so this first line just signals to the cluster, hey, this is supposed to be run using bash commands. As you can see, this second line is just a comment. That's where if you had a more complicated job, you could put how many CPUs you need, things of that nature. This third line, we're making a directory inside of which these training materials will go. And you notice that the path is data user $user RC training sessions. Now this $user, the cluster is going to reinterpret that as your particular ID, because that's what we have it set into. So when you log in, like my Blazor ID is WS Monroe. So if I run this code, I just copy and paste this, but then Cheaha recognizes $user for me as WS Monroe. And so then I make a directory here that's data user WS Monroe RC training sessions, but I didn't have to retype anything.
I'll point out that if you're ever sharing code with other people, it's really good to use $user instead of your actual Blazor ID.
Yeah.
One example is I put something up on GitHub once, it was a little Spartan script, and next thing I know, I'm getting an email from some user at MIT to clone the repository and run it on their cluster, which then emailed me instead of him.
Yeah.
So.
And those are some kind of private information that you don't want out in the GitHub
Find
space.
the web and you just
Oh.
said where.
Yeah, it's right here.
Oh. So GitLab.
GitLab.rc.uab.edu. And it's also in the HPC announce email that we sent out for today if you want to just
Yes, for the email.
I'll leave that up while I finish. Or I'll put it actually over to the side here. All right. So yeah, so this third line here is making the directory, and then this last line, git clone, and then this link, and then a path. So Git is the software that we're using to manage the repository. You can use it, and I think July, Laura's going to talk to us about how to use this to manage our code databases, so that we never lose any code changes, which is really nice. But this way, we can create documentation, make better documentation, and then we can go back to our previous version if we find that we made some error in the way that we were talking about something. But you can also do the same thing with code, where you build up your code, and then you realize your new feature breaks an old feature, and so you can go back to it. So Git is really helpful for that. Clone is just the command within Git to download somebody else's code, or just any code really. And then so for that command you do git clone and then the link to the code repository, and then this last argument is where you want it to go on your system. So we created that RC training sessions in your data user folder. And so so this just says, okay, within the training sessions, put this Singularity container code in there. And then after you have that set up, you can enter these things into the, let's go. If you go up to UAB Research Computing, Interactive Apps, Jupyter Notebook, you can copy and paste this stuff into here. So under environment setup, you put what's in environment setup here. And then under extra Jupyter arguments, you put extra Jupyter arguments here. And then if I start this, it will start the Jupyter Notebook up with the appropriate software preloaded. So that's what this environment setup is. So we're loading Singularity because that's what we need to run the containers. And then this extra Jupyter arguments allows us to tell it where to start up the notebook on the file system. And so so the file system's what helps us connect all of these things up. So like with the RStudio training last month, where you got the code and then you created your RStudio. Since we have the files in the right place, now we can start up another different app on the cluster, and it can look in that same location on the file system and find everything. But with that, I'm going to hand it over to Robbie. If anybody has trouble with the setup, just raise your hand and one of us will come around and try to help you get going. Yeah, no, not a problem. And yeah, so Robbie's going to talk about containers.
All right. Hello, everyone. So, like William already gave away the big secret, we are going to be talking about containers today. And basically what we are going to be talking about is what are containers, why you should use them, and most importantly, how do you use them on Cheaha. So basically, once you have your Jupyter notebooks up, you can just connect to Jupyter, then you should come to this page and just open this IPython notebook.
What is Jupyter Notebook and what does it do?
So Jupyter Notebook is an IPython notebook. So it gives you a format in which you can have your Python code written, where you can provide user with more information about the code that you're writing. So basically, rather than having a comment section, you can provide information in kind of a notebook format. And then there are cells within a notebook where you can write your Python code. Yeah.
Why did you guys do this one as a Python notebook instead of a Bash notebook?
Yeah, so we also had to provide a lot of as a Bash notebook, because we weren't sure how many people had. So last time when we tried to do a Jupyter notebook, some people didn't have the kernel connection to the Bash notebook. So what the semicolon allows us to do is, it doesn't matter what's the kernel that's running, it passes on that particular command to the system itself, and it runs it as if you are running it in a command line space. Alright, we'll begin with a very basic definition of containers before we move on to our first example, because it's always best doing things rather than just hearing about it. So the most basic definition of container is it's an object or a software entity in which you package a software and all its dependencies into that particular object. Those dependencies could be system libraries, system tools, environment variables, or settings. Everything is packaged into that object. That object is also in an executable format, where an underlying container system application, such as Singularity or Docker, can utilize those containers. Alright, so let's begin with just pulling our first container. It's super easy to use, as you'll see. So the basic premise of this example is, let us suppose that there is a neuroimaging researcher. He has been working on a workflow for which he requires a tool called DICOM to Nifty. That's a tool that basically converts DICOM images to Nifty images. And so after some research, he finds out that there is a software collection repository called NeuroDebian that actually contains the DICOM to Nifty tool. So what are his options of using that? The first option is that he can come to Cheaha, try to install NeuroDebian by itself, which has a lot of hurdles. First of all, there are a lot of dependencies involved in installing NeuroDebian. And as the name suggests, specifically the Debian portion. Debian is a type of an OS format. So it's a type of a OS format which is very specific, like Ubuntu is a Debian format operating system. As you might have noticed that on Cheaha we run Red Hat CentOS version. So it's possible to find out the dependencies, the equivalent dependencies on CentOS, but that's a lot of work, and there were already a lot of hurdles, and we are just adding more hurdles to that space. Then then that neuroimaging researcher saw that NeuroDebian folks also provide this to their software repository as a container. So what he can do is he'll go on Cheaha. He knows that Singularity is already installed,
Sorry, here's the sun.
and he can use that to actually pull in that container and utilize all the tools that are available in that container. So first of all, we are going to check if the Singularity environment is available for this particular notebook or not. Like you guys saw when we were setting up the Jupyter notebook, we loaded Singularity. So that means it should be available, but this particular check, you can just come over here, there's a run button at the side, and you can just run it. If it provides you with a version number, that means that the Singularity software is in your notebook's environment. If you see that it's not available, just raise your hands. It means that there has been some mistake while setting up the Jupyter notebook. And the most obvious one is that you might have missed this module load Singularity command in the environment setup before launching. One. All right, so pulling from Singularity, so we are going, the NeuroDebian, we are going to be pulling from Singularity Hub. Singularity Hub is kind of a public repository for container images. And so it's similar to GitHub, like GitHub is a public repository for all the Git repos, Singularity Hub is for container images. To pull it from Singularity Hub, you just need to run the second cell. And it's very simple, you just provide Singularity, the pull command, and the URL for from where it needs to pull that particular container. And once you run it, it's going to take about 15-20 seconds to pull it directly from Singularity Hub. Plus, we have provided links in this notebook, so if you wanted to know more about Singularity Hub, this is a link. You can just open it up and it should take you to that Singularity Hub space. You can find out more information about what they are. All right, so it's done by in pulling the Singularity container image, and you should see that it places a container in your current directory wherever you have this Jupyter notebook. One method of checking it again is just by running the simple ls command in your container. And once I run the ls command, I'll see that I have this container image in my current directory. Now what we are going to try to do is we are going to try to execute a command inside that container. And basically we are just beginning with a very basic command. We are just going to try to run ls for our home directory, but that command is being run from inside the container. By default, your home directory is mounted on the container, so you should be able to see a result for that. And exec is the function within Singularity that allows you to run a command within the container. Alright, so when I run this, I see whatever are the things that I have available in my home directory. Then that means that it was able to run this command successfully. So now the tool for which we downloaded this entire Singularity container was DICOM to Nifty, that is DCM to NII. If I was supposed to run it just directly on my system, I would not find it because that's not currently loaded in my environment. But what I can do is I can again use the exec command, but rather than doing a random command like listing down the content of my home directory, I am running the DICOM to Nifty that's available in the container itself. Now if I run this, it will show me that the DICOM to Nifty is installed in the container, and these are the different parameters that are available with DICOM to Nifty, and I can utilize it from here.
Yeah, so I think it's really important to just double note what Ravi said. DICOM to Nifty is not installed natively on Cheaha. If you go in your terminal and type DCM to NII, it's not going to run. But if you pull a Singularity container, then suddenly you have the power to run this command that you didn't have before on your system. And so that's kind of where this container concept comes in.
Yeah, so we've already talked a little about what a container basically is. One other thing that you need to know,
Could you get bigger, because it's hard to read them. Yeah, bigger.
Does it look okay? Alright, so we already talked about what a container is. If you take a look inside a container, you are going to see that it looks very similar to an operating system kind of file environment, but it doesn't actually contain everything that's available in an operating system. It only contains the libraries or tools that are essential for whatever is the software within the container, whatever are the things that are needed for either to install it or run it. So, for example, if for DICOM to Nifty I needed libc in my environment, that libc would be available in the container image. But some Python libraries I most probably would not have needed with BCM to me. So those things would not be available within that container space. So just to check how the file structure looks like for a container, you can run this next cell. And if you see what's the content of that container, you'll see it looks very similar for people who have actually tried to look into the root directory of their Linux systems. This would look very similar to that.
Now I noticed that has data in it. It has a /data in that.
Yeah, so there is a /data in it, but we are going to be coming to that next.
Is there anything in this particular container's /data if you change it to ls/data?
Yeah, so
there's nothing in there currently. It just has the path already preset.
So there is some more useful information. Containers basically run as processes on your host system. So when you're running things on Cheaha, your host system is Cheaha. And container is just a process that's running on Cheaha. So for example, if you run an ls command on Cheaha, that ls is a process. And similarly, whenever you run container, that also runs as a process. It's very useful because if you have used Slurm job scripts, you would have noticed that you put in the processes that you're running within the Slurm job scripts, which we are going to take a look at again a little later. And containers are basically virtualizations with softwares, and VM, which might be the closest equivalent to a container, that's virtualization of hardware, basically. Alright, so why should we use a container? Containers are, like we mentioned a little earlier, containers are very reproducible. So if you try to take a look at this NeuroDebian container, it's actually running an Ubuntu system inside it. So it means that it doesn't depend what's the OS of your host system, like in Cheaha's case, it's CentOS. If you can build your container on one system and you have a container application on your host system, you should be able to run it similarly without the underlying OS ever being a cause for it.
Quick question. You said one important use of containers is that they are reproducible. And why use a container? If I'm running a simple regression model of my laptop, I know that anytime I write it, I'm getting the same thing. And that's what I'm saying, that I'm able to reproduce what I'm getting. So what is it different from you saying that it's reproducible? What is?
Well, so let's say that you have worked really hard to make your environment functional on your laptop or on your home system that you're doing your analysis on. Now you have a tool that works nicely, and you want to share that tool with somebody else. So you send it to Professor XYZ at University ABC, and he says, I tried to run your code, but it told me that I needed this dependency and this dependency and this dependency. So what you can do in those instances, and we're sharing links at the bottom of this, is either you can develop your code on top of someone else's container that they've already built, to where when you send your code, you say, just download this container and run the code in there and it'll work. Or you can build your own container from scratch, which even contains your tool. So for instance, the neuroimaging community has this tool, MRI QC, which is a quality control metric for their images. And it has a lot of dependencies, and it's very difficult to install from scratch, but it's built as a container, and so the whole community, whether or not they think about it too much, they end up using this container workflow, because instead of having to spend all the time to just building the environment to get this one tool to work, they can just pull the container and then just start running immediately.
Yeah, and once you pass on the container, it doesn't matter. So if you were running Ubuntu on your system and you were doing those regressive testing, and the person that you're sending the container to is running CentOS and some other things, so it wouldn't matter if in the host environment they had certain dependencies or not, because all the dependencies are already contained within the container. That's what makes it reproducible on different OSs.
Just one quick question. So I guess one advantage over like Honda is just really the time spent installing, right? Okay.
Yeah, so I actually ran into this exact same issue recently. I built a machine learning model, and I wanted to have the materials engineering folks use it. But I didn't want to have to go to each collaborator's office and build a new Anaconda environment for them that matches my Anaconda environment. So what I did was I found a container that had the appropriate Python libraries in there to use the machine learning model to inference their images, and then just call that from a Matlab script. So now instead of having to go and build them an Anaconda environment, which would also be reproducible, we could make sure it matched mine, but it's even lighter weight than that, because now there's just a Docker container image on the cluster that Singularity runs to do the machine learning portion, and I have that called from Matlab, and so it's pretty slick, and that all they see is they're opening up Matlab and running a script.
What if like the pipeline or whatever already builds that home environment automatically?
Then I think it would be up in the air. I think the Docker containers tend to be more lighter weight, and so if you're looking for something that's going to optimize the space required, or even the time to call the code, because I noticed when I used my Anaconda environment to do the inferencing, it took about twice as long as using the Docker container.
Yeah, and plus containers allows you to create a snapshot of the image at a particular time. So for instance, this NeuroDebian, this .s image is kind of a snapshot of the container at this particular time. So we ran it at 120. So at 120, this is what the image looked like. With Anaconda installs a lot of dependencies by itself, but it still depends upon some system libraries, which can be updated over time. So the next time you might be trying to recreate your entire environment, it might be that there might be a slight change in that environment based on the underlying system libraries that have been upgraded. And like now, if you have the Singularity image, you can just pass it out, and it would be in the exact same state as it was at 120. And if I pass it out after 1 year, it would still be in the same state.
So, from my understanding, I don't know that much about. So the container is kind of store stuff, right?
Yeah,
Is that
except
size?
instead of storing your files, it's storing your environment.
Also environment. So because I want to store lots of image and share with somebody.
Yeah, so it would be possible to store images inside of a container, but then it would become as large as your image data set.
Yeah, and that would be, so mostly containers when they were built for distributing complex softwares where you have a bunch of dependencies. And so it, like William mentioned, it's possible to build a container image just containing your images, but you should be able to use just rsync or other tools for sending out your data.
Are you interested in making a container for this contest workflow? Yeah.
The Dream
okay.
channel.
Well, maybe we should have another conversation about that afterwards to see, or set up a time to talk about it to see, because that's a workflow we're not as familiar with, to containerify the data. But I know for challenge workflows like that is something that happens.
All right, so the next thing that I mentioned is that you can run your container commands in a Slurm job script as well. And we are going to be taking a look at a sample Slurm job script using this NeuroDebian container. So the next section is Docker versus Singularity. How many people have heard about Docker and Singularity? Yeah, not many. Yeah. So people who haven't used containers as well, they also know about Dockers, because Docker is the most widely used and most popular container system available in the industry. It's very easy to use. It has got great documentation and it's very easy to install. So why are we using Singularity on HPC systems? Because the end goal or the problem that Docker was trying to solve is different from what Singularity tried to solve. So when Docker was built, they were trying to come up with some microservice architecture for their application types. And so in those kind of software development, it didn't matter that if the containers are running some processes as root of the system. In an HPC system where it's a shared environment, everyone has an Cheaha account over there, right? You don't want any process to run as root, because if you allow someone to run as root, there is a distinct possibility that they can escalate their privileges inside a container, and then they can become root and shut down the system or go into different folders where they are not supposed to go. So those are some of the considerations which Singularity had in mind when it was created. And but the point was that Docker came way before Singularity came. Singularity got released in 2016 or something. So a lot of researchers and a lot of people who provide softwares were already using Dockers by that time. So the other objective of Singularity was to have some sort of compatibility with other systems. So that means that Singularity should be able to pull in even the Docker images and run. They don't give a 100% guarantee, so I cannot give you 100% guarantee for that as well. Let's just say 99% it should work. And just like Singularity, Docker also maintains its hub. That's again a public repository for container images. And Singularity is already available on Cheaha. We already have loaded one version of Singularity. To see what are the other versions of Singularity available, you can just run module await Singularity. By the way, like I was mentioning earlier, if somebody missed, you should be able to write these commands directly on the command line, leaving out the exclamation point, and they should give the same result that you're seeing over here in the output. And so these are the Singularity versions that are available. If you are not interested in getting the latest one, you You can choose other versions as well. Alright, so now we are going to take a look at some of the Singularity functions or commands. We have already looked at pull and exec, and there are some other ones that are useful that we are going to take a look at. So like I mentioned, exec uses command, it executes a command from within the container. Run basically launches a run script within the container. So this depends upon the person who has created the container. So for example, if I was creating a container which was only supposed to have DICOM to Nifty tool inside that entire container, what I can do is I can create a run script where whenever someone runs Singularity run this container image, it automatically starts DICOM to Nifty. If you have multiple applications, then it becomes kind of like which particular command should you expose to this run script command. And similar with the test script, that also depends upon the person who has written the container, if they have provided with a test script for the container or not. One interesting uses command is shell. This basically starts a shell from within the container. It becomes kind of an interactive process at that point. You get into the container and you should be able to run things from within it. It's difficult to show it from a notebook, in a notebook format, because every time the shell starts and then it goes into that waiting mode, because you cannot enter any information over here in the notebook, and then it just keeps being in the loop till the time you interrupt the kernel. So, but if you want to see how it looks, we can actually, sorry. Alright, so what we'll do is, and if you just type in Singularity shell, and you'll see that it has started up a prompt for you, and this is an interactive thing now. You can just go over here, type DICOM to Nifty, ls, your home directory, and all those stuff. But like I said, in the notebook format, you cannot actually do anything over here, so that's why we didn't include this particular thing. And you just interrupt the kernel once you want to cancel this job. Interrupting the kernel basically runs Control-C command. Alright, so we already saw the pull command. It basically pulls a Singularity or Docker container to your present working directory. That's what PWD stands for, the present working directory. And the other useful command is build. This is basically when you are trying to build a new Singularity image from a Singularity recipe file. So there are methods by which you can create your own Singularity containers, and for that you have to basically create a Singularity recipe file. That's beyond the scope of the session what we were trying to do today, but we have provided links at the bottom if you're really interested at the end of the notebook, where you can go and see how you can build. And if you have any questions, you can definitely come to our office hours, and where we can help you in creating your own Singularity containers as well. That will become really useful when you have your workflows ready and you wanted all the tools to be available within one particular Singularity container. Then creating your own recipe file might be really important. Alright, so there are some other commands as well, but these were the most important ones that you are going to be using. If you wanted some more help about one particular command, you can use that particular function in conjunction with the help command, and you should get more information about it. So if I just wanted to find more information about Singularity pull, I can do a Singularity pull help, and it should give me more information about what are the other options that I have that I can put in there, and some examples and some text about what this command is. All right, so namespace resolution within the container. So like Curtis mentioned that our container already had a default /data location. So what we are going to try to do is we are going to try to exec an ls for data user, and $user will go to your Blazor ID. And once you run that, you'll see that it cannot access your data user Ravi89 or in your case your Blazor ID location, because by default the containers only bind your home directory and temp directory to the container. That's a problem, because we have been telling you for all of our training sessions that keep your data in data user location and don't keep it in your home directory location. So we need access to that data user location somehow, because that's where our raw files are going to be. The neural imaging researcher at the top, he won't be able to use DICOM to Nifty if he cannot access his data user location. So
When you bind it, can you bind it as a different name, or can you?
You can bind it as a different name, but again, for
Like-
portability of the script to other people on Cheaha or things like that, or just to make it easier to remember where your stuff actually is.
I meant more like, since they already have a data container, that data container actually contains something important.
Yeah.
Sorry, not container, directory. We could have mapped our data as Cheaha data or something.
Yeah,
Yeah.
exactly. Yeah.
yeah, so thankfully Singularity provides you with a parameter which you can use to bind your host system's data locations onto the container system. Basically, it's just -B, and then you provide the name of your data space on your host directory that you want to bind to the Singularity container. So for in this example, I have already binded my data user location to the container, and now if I run this again, now it's going to show me all the content of this, all the content of my data user location. Now I can run that DICOM to Nifty, and even if I had some DICOM files in my data user location, I would be able to point it to those particular files. Alright, so one thing that I forgot to mention during why Singularity over Docker is, one other thing Singularity does is so the user that you are on a host system, it's the same user that you are in a container context. So whatever permissions that you had on your host system, that is Cheaha, those are the same permissions that you had on in the container. So for example, if I wanted to be like, if I go into the container, I might be able to access William's data files. That won't be possible because it wasn't possible in your host system, and so it won't be possible in your container as well. And when I try to do that, it's just going to give me permission denied error, which it would have given if I wasn't running it on container and just running it outside anyways. Alright, so like I mentioned, now we should be able to use DICOM to Nifty tool. But how do we use it with Slurm job script? So this is a very sample Slurm job script that's going to utilize the container that we pulled and run it with some DICOM images. So for people who have already seen what a sample job script looks like, nothing changes over here in the section where you are requesting for resources about the time and partitions and standard output and standard error files. It's similar to how you'll do it for any other job scripts. Basically, when you are setting your environment, you load the Singularity tool because you need the Singularity tool to actually run the container. And then you specify Singularity exec dash, I'm binding the data user location because that's where my DICOM files are. And then I provide a path to my image, Singularity image or Docker image file, and then DICOM to Nifty and paths to my DICOM files.
So my current environment variables, such as my Slurm course stuff, will bleed into the Singularity image unless I tell it explicitly to not carry over my environment. Is that correct?
I think so.
Yeah, I think so.
I'm thinking, we need to be able to talk between the Slurm resource allocation
Yeah.
and then actually.
I believe
how it
as long
runs
as
on
it's
its
not
own.
one of the important environment variables for defining, like host stuff, like your load library path isn't carried over into the Docker container or into the Singularity container. But like where a user gets resolved appropriately, if you do an ls data user $user, I think it'll be resolved appropriately.
All right, so yeah, and you should be able to just submit this job, and Singularity should be able to run your DICOM 250 workflow that you were trying to run in the first place. All right, so we also mentioned that Singularity has compatibility with Docker images. That's what we are going to see in the next section. So the tool that this particular Docker image has is Cloud Sdk Tools. They are basically Google Cloud SDK tools. So they contain several utilities to interact with Google Cloud Platform. So for people who are not aware, you might have heard of AWS, right? Google Cloud Platform is the equivalent of AWS, but by Google. And similarly, Microsoft has Azure, that's also equivalent. And so these Google Cloud SDK tools allow you to interact with your Google Cloud accounts, storage locations, and all the other things directly via command line from anywhere. And so there's another, so again, I have a choice: either I can install it directly on Cheaha, and for which I can send an email to support@listserv.ub.edu, or since I already know that there is a Docker image for it, I can just pull it myself and utilize it. And so basically you'll notice that from S hub, it has changed to Docker. That basically denotes that it's pulling from Docker hub right now. And this user has a lot of other very good tools as well, which you might want to check out. I provided her a link for her repository over here if you are interested in that. Alright, so I'm going to run this. It's again very simple. It's Singularity pull and just pull from this Docker hub image now. And now it has built up a Singularity container again for it called gcloud.simage. And when I run one of the tools that is available in this container, gsutil, you'll see that I would be able to find this gsutil command within this container. If you guys have AWS services, this user Jess, like I mentioned, she has a lot of useful Docker images. She also has one Docker image that's called AWS Clean. It's again command line interface for AWS services. And the last command is basically once you are done with your entire container, entire notebook, you can just run this and it's going to remove all the container images from your current directory in case you wanted to run it again at a later date. And so yeah, like I mentioned, this containing a Singularity recipe file is, well, it's beyond the scope of this session, but here are some important links that are going to allow you to build your own recipe files. Unfortunately, for building your own Singularity recipe files, you need to have sudo privileges on the system that you're building. So you need a system where you'll have sudo privileges. I mean, your laptop is the most ideal candidate. You all have sudo privileges on your laptops. So you should be able to install Singularity on those systems. Here are links of how you can install it on a Linux or a Mac or a Windows, and then methods of creating a Singularity recipe file. Again, if you have any questions once you start creating your own Singularity recipe files, you can come to our office hours and we should be able to help you in creating your recipe files. And yeah, these links should help you as well. We have started using a lot of Singularity containers on the cluster itself. One of the most prominent example is the RStudio session. So the RStudio that you see in Open on Demand or just by the basic RServer command that was available on command line before this, that uses a Singularity container that runs RStudio behind the scenes. So that's the most prominent example of how we are using Singularity containers. So for instance, whenever you go over here and, whenever you start an RStudio server, it's starting up. It has a Singularity image in the behind the scenes kind of thing, and it's running a Singularity container over there. Other tools that we have used are OpenMVS and Colmap, and I believe someone is using MRIQC Singularity.
Yeah, the
image
Lottie
as well.
Lab is using MRIQC.
So how does licensing work for these containers? You talk about creating a container, sharing with someone else. You're sharing the environment. The environment includes the software. If it's a licensed software, how does that issue?
Yeah, so if you have a licensed software inside it, Singularity recipe files allows you to pass some environment variables to the Singularity container. Most of the time, if it's licensed, software providers allow you to define an environment variable where you can define where the license file is or the license manager server is. You can define it over there and they should be able to run it through that. You have to keep in mind though that if your license server manager is running on UAB network and you provide that container image to someone outside of UAB, and wherever the license server is running and they're very strict about that only if you're running on UAB network that you will be able to access license. In those cases, obviously the container image transfer won't work. So
Yeah, but like when there isn't a licensing server or license file, wouldn't someone be able to exploit licensing? Like I create an environment with a licensed software and then send it to someone else who doesn't have that license, but who hasn't paid for it, and they're using it.
yeah, I mean,
I think the answer is it's possible. It's not something that we've come across yet where
It's a problem.
where somebody's encountered that as a problem. And there may be some workarounds if that's something you're concerned about that can be implemented.
yeah, that's mostly because we generally deal in the open source environment where where the licensing, you have some license agreement where you're like, oh, if you make changes to it or something, the credits and all those things. But if you're
it's
trying,
Matlab or something and you're sending it to another colleague, their institution probably has licensing.
so if you are trying to sell it, trying to sell a licensed product to someone else, there are a lot of different options that you can utilize. For example, I was working with a user in which the person who provided the software, what they did was they created a license file which was based on the particular server that you were running, and it checked every time that you were still running on that particular system, and if it wasn't that particular system, it just never ran anything. So there are some other tricks like that you can utilize, but yeah.
Yeah. And that's something we can look into more. The NVIDIA GPU Cloud has the Matlab container on there, and so I don't know how they handle the licensing for that.
Alright, so that's basically it. If you are interested in finding out more, there are some useful links at the end of the document as well. And I mean, basically, if you are running things on your system, just your system, and you're not interested in running on the Cheaha, then Docker is a good option as well, because on your systems you should be able to run something with a root daemon. But everyone wants larger resources once they want to scale up. At that point, Singularity Singularity containers are more useful. So, and if you guys have any other questions, I can take it now. All right. If you guys have any, or if you guys come up with any more questions after this, you can come to our office hours that are on Thursdays from 10 to noon, and Wednesdays 1, 2, 3.
At this time, yeah.
At 1, 2, 3.
Yeah, so a couple of other quick announcements since we're done with the Singularity portion. Y'all may have noticed that if you go to the dashboard, it no longer says beta. So, so that's the way that this primarily impacts you is if you happen to be at Starbucks and you want to check on your Cheaha, you don't have to be connect to the UAB VPN. So now anyone anywhere can access the rc.uab.edu as long as you have a Cheaha account and the appropriate authentication, but you don't have to have the VPN to connect any longer with that. The other thing that you may have noticed if you've been playing around with it is that we've added Matlab as an interactive app. So now, just like with Jupyter or RStudio, if you click Matlab here, then you can start up an instance of Matlab where you can run your code without having to start up a desktop and then load the modules and all that stuff. You can just come here and click launch, and then after a few few seconds or a few minutes, depending on the load on the cluster, you'll have your Matlab.
Can you run like a SAS program here?
So SAS and ANSYS are two apps that are in development right now. So I don't know exactly where it's at in the development, but I know it's coming soon. So yeah, so SAS is coming soon. If you want to run SAS right now, you can go open up the HPC desktop, and if you want to come to office hours, we can show you how to start up SAS from the desktop.
Cool.
Yep.
Is it possible for us to add our own interactive apps at this point, like in our own account?
Not at this point, but that's something that we're exploring because the software that we're building this platform on has the capacity to have a developer mode, and so then we would be able to enable that feature for folks like yourself who have an interest in developing your own apps for it.
When you say apps, does it include Emacs? Let's say you want to run out through Emacs instead of RStudio. Can that be done?
I think if you wanted to do that right now, the best way would be to do that at HPC desktop and then start up Emacs inside of there, because we have Emacs installed. Yeah.
Yeah. So
there is an Emacs you get by default, and then there's a more recent version you can load with the module. So if it seems ancient, there's a module for the more recent version of Emacs.
we might also be interested in using the file editor that gives you some sort of Emacs settings, especially in saving and things, I believe. But
Which editor is the file editor based on?
yeah.
I don't know what what's the
Yeah, just use, use this edit.
let's see, where's it edit? Yeah. So this is the editor within the text editor within the file browser, and you can actually change the text highlighting. It tries to detect it since this was a notebook. It wasn't sure what it was, but it generally will do a pretty good job if it's a Python file of showing you Python highlighting, or if it's R code showing you R highlighting. So you can also edit files this way if you don't want to go to the full extent of starting up RStudio or something like that. The other thing that we were gonna let y'all know about is Ravi and I have started our recording our data science club sessions. So expect an email in the next week or so about where the YouTube channel is. So as part of that, what we're doing is taking a live stream YouTube video while we're doing the notebook, and then we have the link to the notebook itself. So then each week you'll have kind of a companion set of data. You'll have a notebook with a nice example for you to run through, and then a video of Ravi and myself running through that code. And then in the future, eventually we'll get to the point where we'll let people know when we're doing that, so you can log on and watch the live stream while we're doing it and ask questions while we're running the notebook. But until we hammer down all the details, we're just going to be taking the videos and then posting them. So yeah, but again, if there's any questions, come to office hours or shoot us an email or anything. So thank you guys for coming.
Thank you.